All right, so we're going to be learning about ellipses today. Just another conic section in our units. So let's take a look for an ellipse. This is the set of all points P in a plane such that the sum of the distance between P and two fixed points called the foci is constant. So foci is actually plural for, apparently changing the slide, for focus. So just stop changing slides. Okay, so this would be singular. We call it a focus. Foci would be plural. So the foci lie on the major axis, which basically means the dominant direction of the ellipse. We'll get to that in a minute. The major axis connects the vertices. And then again, there you see that dominant direction. Along the dominant direction, the minor axis is going to connect the co-vertices. Sorry, pen issues. Here we go. Vertices. All right. And that goes along the non-dominant direction. So that's important that we keep those straight. So vertices are dominant direction. Co-vertices are non-dominant direction. Sorry. There we go. Just quick fix that because you couldn't really read it. That's better. Okay, so looking at our pictures, the first one we have here, this is called a vertical ellipse because the dominant direction is vertical. That would make this the major axis. And that makes this one the minor axis. And also over here to the right, we have a horizontal ellipse because the main direction is horizontal. That makes this the major axis. And this one, the minor axis. So the major axis, again, is going to connect our two vertices. So each vertex at the end. But then the minor axis is going to connect the co-vertices. Other things that we want to make sure we recognize here, we have HK, which is the center. And then in purple, the foci. Those are those two other points right there. Those are the foci. Other important values, the A, B, and the C. These are very important for all ellipses. So A is the distance from, can't spell from apparently. Try that again. That would be the distance from the center to a vertex. So that's important. That's A. I'm sorry, I was just double checking that we have everything in order. Sorry about that. Okay, so A is the distance from the center to the vertex. You should definitely write this down. Very important. And also something else about A. This one is always the bigger number for an ellipse. Then we have, so that's really important, bigger number for an ellipse. We have B, which is the distance from the center to a co-vertex. Okay, then the last one is C, which is on the graph, on the picture here. C is the distance from the center to a focus. We don't use that as much at this stage in our mathematics, but it is there listed on your picture. It's the distance from the center to a focus. And the other ones are there as well. We can see A is the distance from the center to the vertex, and B from the center to a co-vertex. So again, we have these two lovely charts for you to help you out. Here's all the information for vertical and horizontal. Vertical meaning our ellipse is up and down. Horizontal meaning our ellipse is left and right. So the direction of our oval shape. If you look at the two equations, the only difference between the two equations is where your a squared or your b squared is. So when you're looking at these, you can tell the difference between horizontal and vertical by looking for where a squared is. And remember this one I said a minute ago, this is the bigger number. So when we're looking at ellipses, we're looking for the bigger, I just circled B. Sorry about that. Let's make sure we're on A. We're looking for the bigger number. The bigger number is going to give us the direction of the ellipse. So we'll see that in just a minute. All right, then we have some formulas for the vertices, co-vertices, and the foci, but I'm not going to get into that. And this equation at the bottom, we're not going to use this year. This is something when you get further in math, it has to do with finding the focus and such. It's there if you need it, but we're really not going to use it. So there you go. So let's get some steps down and let's graph. It says get the equation in standard form, which means complete the square. If necessary. Find and plot the, not vertex, excuse me, the center. Which is H and K. Use the values of A and B to plot the vertices and co-vertices. Connect the outer points, not the center, with a smooth curve. So it's very similar to graphing a circle. It's just we have different distances for different directions. You'll see in a minute. And let's go on to graphing. So example 1. First thing we're going to figure out, is this, not example 2, is this horizontal or vertical? To figure that out, I need to know where the a squared is, or the bigger number. 25 is bigger, so this is my a squared, and that makes the 4 my b squared. So this one is going to be horizontal since the a squared is under x. So if the bigger number is under y, it's going to be vertical. If the bigger number is under x, this one is going to be horizontal. Then I have my center. I'm going to move that down just a little bit. We have the center at HK, which is going to be -1, 3. So on my graph, over -1 up 3. Then once I have the center, then I'm going to use A and B to move in the appropriate directions. So that's where it says it, but let's go on. So A squared is 25. What does A equal? Should be 5. And we said A is underneath my X, which means it's horizontal. So A is going to be a lefty-righty direction here. So from the center, I'm going to go left 5, 1, 2, 3, 4, 5, and right 5, 1, 2, 3, 4, 5. Then I do the same kind of thing with B. So B squared equals 4. So B then would equal 2. Since B is the non-dominant direction, this one is going to be up and down. So I would go up 2 and down 2, and then I have all my points and I connect the dots. Nice smooth curves. There we go. All right, graph this one. First thing I look for is what direction. I look for the bigger number. Here it is, 16. That's going to be my a squared. Since it's underneath the y, this one is going to be vertical. So then I need the center, which is at -5, 1. So on my graph, -1, 2, 3, 4, 5. Maybe I lost count. 3, 4, 5, 1. And then my a squared in this case is 16, which means a is going to be 4. For this problem, since the a squared is underneath y, it's going to go vertical. So I'm going to go up 4 and down 4. Then I need b squared to go in the non-dominant direction. And so